All right, so this particular, we're gonna finish at noon. No matter what, we'll take a lunch at noon, and we'll stop there. We're gonna try to solve as many of these problems as we can using test-driven development in Jest, because I think that is what everyone has asked for. Now, personally, I haven't used Jest before. I just passed off the documentation because that's what a senior engineer generally does. Even if I were to go into a place and a more senior engineer comes in and he goes, you have to learn this. Okay, let's Google it and figure it out. So I also have no idea how to use Jest, so I'm pretty much at the same level as you right now. That being said, I've got more years of Googling experience and more like how to search. So I'll talk through my thought process on how to get this one set up. Is there a challenge that stood out as more difficult that you'd like me to go over?
I think the credit check one is probably the best one as far as difficulty.
Sure. All right, so first things first, I'm going to just go over the Jest documentation. And the way that I generally do it is I try to make like a very simple example work, and then I will translate that into a credit check, and then we'll write the code, and hopefully we'll do that in the next 50 minutes. So Jest, I mean, it's kind of like, excuse me. It's kind of like the holy wars between like different text editors or different like front-end frameworks. I got popcorn stuck in my throat. There are popular ones, and then there are people who argue that there are more popular ones. For the sake of argument, because I basically pulled my wife, who's a professional JavaScript developer, as well as a bunch of people who I know work in JavaScript. They're all like, Jest is probably what we use the most. I have heard of Mocha Chai before. We used to use that, but people seem to be using Jest, so might as well. It's very, very small differences. So like once you master one, it's very easy to transfer to the other one. I know how to use unit tests because our spec in Ruby is the same thing. All right, so let's take a look. So we're going to install using yarn. We're not using yarn, we're using npm. So we're going to save dev jest. Okay, interesting. Let's go here. I'm going to go to my desktop by cding into the desktop. I'm going to make a directory called jest example. cd into jest example. And I'm going to open that whole thing up inside of VS Code. I don't need to go over the terminal commands anymore, right? Yeah. I think we're all confident in those. So I'm just going to copy this, npm install save -dev jest. So if this works, I'll explain what that command does. We were going to cover this next week, but I might as well go over it now since we're already here. So npm stands for Node Package Manager. There is what's called vanilla JavaScript, which is just JavaScript without any plugins, no libraries or anything. And that's kind of what we've been using so far. It's just write the functions, you create your variables, you create your loops. Vanilla JavaScript, nothing added. Node Package Manager includes a bunch of packages. Those are also called libraries and gems in other places. But essentially what that is it's thousands of lines of code. Somebody else wrote it ahead of time in vanilla JavaScript to make your life a lot easier. So imagine if you had to write your entire own testing framework. Why would you do that? You wouldn't. So that's why we have things like Jest. Somebody installed Jest. Somebody created Jest for us. It was created, it's an open source repository. What does open source versus closed source mean? What's that? You got it right. Yeah.
You can create a version of your screen and put it into the, you'll have to submit a request for it.
Yeah.
It can be updated.
It can be updated, exactly, yeah. So open source software means that all the code that's underneath the hood is open to everybody in the world. Everyone can take a look at what's going on inside. So things like Python, Django, React, like React was created by Facebook, but they didn't make it closed source. They made it open source so everyone can add to it. Closed source is things like Adobe Photoshop, Microsoft Word. You don't know what's going on underneath the hood, and you most likely need to pay for it. So those are the two differences. So Jest, all the code lives right over here under the GitHub repository, created by Facebook. That's pretty cool. And I think that's why it's popular. It's because if Facebook backs something, usually when a large company backs a framework or a library, it'll be around for a long time. And just this week, there were 4 million downloads. Cool. All right, so I ran through this, and it created 2 files for me, a package.lock.json and a node modules folder. Let's see if I can run this example, and I'll explain what these 2 are. So I'm back on the getting started. I installed it, and I'm going to create a sum.js file. From there, I'm going to have this here. Jumping back to this, and then I'm going to create a sum.test.js file.
Real quick, did you Google the JST or did you already have this website? Oh, right there.
All right, so the next thing they tell me to do is sum.test.js and paste this code inside of there. Now it says add the following to your package.json, okay? So if you look here, I have a package lock.json, but a no package.json. So I think I need to run npm init. And there's my package.json. I'm going to put scripts test inside of there. So there's a scripts, there's a test. I'm going to get rid of the one that already exists. Type in Jest. From here, finally, I can just run npm run test, and Jest will print this message. Let's hope that this works. I'm going to clear the screen, paste this in. Please, don't embarrass me. Ran all test suites and everything did pass. Okay, so that's it. So so I have a lot more experience, so it makes a lot of sense. So first things first, I want to explain what Jest is, and I think we did that using this node package manager. So Jest is a library. A library is a bunch of code written in the language that, so this is node package manager. So it's Node, which is JavaScript. So it's JavaScript code, tens of thousands, millions of lines of code that someone wrote to make your life easier. Imagine if you had to write all of this code that magically worked and tested all of your stuff. Basically all of this. That would take forever. So you use other people's code ahead of time. Node Package Manager is a company that's based out of Oakland and publicly funded to basically keep track. It's like the yellow pages of every single Node library ever created. So React is on here. Owned by Facebook, 5 million downloads this week. So these are all just libraries. npm install is the command that you run to install certain libraries inside of React. So generally speaking, I do npm install Jest or React or D3 -- save. And what that -- save does is that it saves it into your particular computer at that particular repository. That's why I created a separate folder. It's installed right over here. When I do save -dev, it just is a development version saved onto your computer. So that's the first thing. I want to reach out to npm and install Jest onto my machine. It looks like I have some sort of, I have some file inside of JavaScript, and then I have some file that's the test version, test file for that version. So usually you can kind of see with Python, I have the name of the file, and then the name of the file _spec. I guess I was wrong when I wrote the challenges, but now it is something.test.js. That is the proper way of doing it. That is a good point, and we will make note of that. Any question?
Can you go over what the require function is?
Sure, I'm going to go over every line. But until then, let me write down change to x.test.js. So I created a file called sum.test.js, and I pasted this code inside of there. So when I ran npm install, this command right over here on the bottom, when I installed it, I got 2 things for free. I got the package lock.json and the node modules. So node modules, basically, the reason why JavaScript is so fast is because it operates on each individual person's machine. It doesn't make a request to the server, which doesn't make any sense yet, but trust me on this one. Node modules includes every single JavaScript library that Jest requires in order for it to run. So underneath the hood of Jest, it requires all these other libraries, and all these other libraries require other libraries, and those other libraries require others, and that's why we have all of this code right here. When you go inside of one of these, and you just jump inside of the JS, there's a ton of extra code that you may or may not ever need to know, but this is all the stuff that's happening under the hood just to get this tiny little thing down here to pass. Now, inside of sum.js, basically what's happened here is in Python, you don't need to import and export files. In JavaScript, you do. What this is saying, this is the same as saying exports what was the other one? Exports dot something, or doesn't matter. So the idea here is I am writing a function, but if I want to use it outside of this particular file, sum.js, if I want to use this method that I just wrote between lines 1 and 3 outside of this file, I have to attach it to an exports so that it can be used externally. So basically I'm saying I have an export object, and inside of there I'm going to put the sum. So I can use the sum outside of this file right here. What this is doing, let me just close. What this is doing on line 1 is basically saying, I'm setting a variable sum to the sum file over here. The sum file has an export. Inside of that export, there's a sum method. So suffice it to say, this line right here is essentially saying, grab the contents of this file and save it to the variable sum. That's all it's doing. This requires basically saying, I'm bringing in code from another file into this file. I could do the same thing by just copying and pasting this, getting rid of that. But again, we want to write the code in one file and the tests in another file. So I write it in this one file, and then I require or import it into this file over here. Now the tests seem pretty simple, which is the word test, some sort of message for myself, that's this thing right here, and then a fat arrow function, which we have covered or have not covered yet.
Josh touched on it.
Josh touched on it? Okay, let's talk about that real quick before we move forward. Yeah. So function sum A plus B, pretty simple. I've got a function. It's called sum. It takes in 2 parameters, A and B. I'm going to make this a little nicer just so. Number 1 and no. Gosh. So this is the old school way of writing. It's just kind of like, I mean, when we were kids, legit wasn't a real word. It is now. If you go to dictionary.com, legit is actually a real word. Or literally, in the past, used to mean something different than what literally means in the dictionary now. So things change over time. The JavaScript code that we wrote a long time ago looks a little bit something like this. It'll still work, but there is a new version of it. So we've got a fairly simple function. It just says sum. It takes in 2 numbers, number 1 and number 2. And all I'm doing is adding those together and returning that out to the screen. This is totally fine. This is what's called ES5, ECMAScript 5. So the full name for JavaScript is ECMAScript. And this is the 5th version that was released a long time ago. So ES6 was the most recent major rewrite. It came out in 2016. And the way that they want to do functions now, it looks a little something like this. So const sum equals number 1, number 2, return number 1 plus number 2. Lines 1 through 3 and 5 through 7 are identical. It's just, this is the new way of writing functions. What they did, if you're more advanced, is they created what's called a fat arrow function. This is the fat arrow. It automatically binds the context of your variables to that particular place that you call it. And if that doesn't make any sense, you don't need to worry about it for right now. But as we start writing code, most places are going to ask you to move towards this particular way of writing code. That's what we've got here. So this is just some sort of function. I expect when I call sum of 1 and 2, I expect it to be 3. And that's what we've got right here. What other things did we install? The last portion that I think people got really confused on is this package.json. So package.json.lock came to me for free. This was something that happened when I ran this command down here at the bottom, npm install --dev just. This basically is a manifest. It includes every version of every single dependency that Jest requires. And you can kind of see from this here on the right, there are 4,900 lines of dependencies. So if you don't want to keep track of that yourself, you just trust the package.lock. So when I run Jest, it's using Babel, code frame version here. Here's where it's registered. Here, like, it just keeps track of all the different versions for you. But what package.json requires is that when I run something using like npm run anything, it requires this file, and it's a pretty. This is simply another version of like a manifest. So this is the name of the file that you're running. This is the version of the file that you're running. This is the description. Just trying stuff. It's basically a write-up of everything that you need to know. So this one says I require these particular dependencies, and I have got a script. A script is the same thing as writing like a shortcut. So when I run npm run test, I'm just running npm run jest. The way that I got this particular file to work was I run, where is it? npm init. When you run npm init, it's basically saying I'm initializing this particular folder that I'm in to be an npm folder. Same thing when I do git init, I'm basically saying I'm making this current folder a git repository. And don't worry that I did that pretty quickly. It just comes with a lot of practice. I'm going to go with Mariah first.
So, in the, right here, the sum,
yes.
is that doing what you think it is? Because we had to use sum dot the function name contained in the JS file.
Yep.
And here sum, in expect, is that calling sum from the file, or is that just another top level function called sum? See, right? Yeah.
Sure. So on line 1, so line 4 is calling line 1. This thing right here that I'm highlighting is calling this. The require is pulling in the sum function found here on line 9, which calls line 1.
Could you try line 4? Sum.
Sure.
Could you put dot sum?
Dot sum like this?
No, sorry. Sum dot sum.
Like that?
Just try running it.
Sure.
Just a bit confusing that because we had to dot. Yeah, I don't know. We had to dot the variable we called it from. We had to dot into our function.
It's possible that the way that I set up exports is different from the way they set up exports.
Okay.
So that might be a reason why.
Yeah.
So looks like you can call sum from the directory, whereas we were selecting our function from the file, I think.
Yeah.
Yes.
Like, okay.
Answer your question.
So exports is sending sum to where it's usable by that directory.
Correct.
So the way from modules, the way that modules got exports, let's say if you wanted to do your own functions and write them and use them anywhere in your code file, then you're making your own built-in methods, and that's what you're exporting to. So if you said .sum, it'd be like a prototype, like when you do the name of your array .length. That's a built-in method, but you can also build that and then use that export modules.export. So your own built-in methods.
Yes. So there are. So to reiterate what you said, there are built-in things there are built-in methods for JavaScript, like .length. Array.length is going to be built in in a JavaScript file, this one or this one, because it's a .js file. Because it's a .js file, there are things from the standard library that are brought in. When you write your own custom method here, like this module.export, like this 1 through 3, and you want to use it somewhere else, you attach it to an exports object, and then you import it by using this required. Yep.
And then the next question, or actually the question I have is, when we're pushing our code up to GitHub, how do we make sure we don't push up the packages that were installed?
Good
and
question.
Else?
That's a good question, because it probably took a long time to push, right?
I know one of it. That's like a big one that was
sure. We'll talk about
me up.
We'll talk about that once we solve this problem, and then I'll, because I don't want to push that up either. Henry?
Just a remark. So when you hit npm init,
Yep.
I saw you hit a key like a bunch of times.
I pressed enter a bunch of times.
Okay, why was there any? What did that have anything to do with you hitting package.json? Because I mean that's where I'm at right now. I haven't been able to.
So if we installed it correctly on the first day, good just example, and I run, let's just say if I remove the package.json and I want to create a new package.json file, it's just npm init, basically saying, hey, npm, I'm going to make this particular folder that I'm currently in an npm folder. And the way that they do that is by inserting this package.json. So the package.json lists out all the dependencies. The package.lock.json tells you which version of those dependencies you need to use. When I type this in, I just press enter a bunch of times and I trust everything.
Oh, got it. Okay.
And then if I list out everything, there's that package.json that wasn't there before.
You said package lock JSON tells you the version. Okay.
Yeah. So let me open this whole thing up real quick. So again, package.json is a manifest. It lists out the name of the thing you're trying to, of your npm file, the version, the description, and any dependencies that you have. Package.lock keeps track of all the different versions that are required to use for this particular bits of work. The reason being, let's say that, so there are companies that have written code from a long time ago, like early 2010s, and there are versions that came out in the early 2010s. If you upgrade to the most current version, it's going to blow up. It's like saying, let me take a Ford Model T from the 1920s and put a Corvette engine inside of it right now. Obviously, that's not going to work. You need specific engine parts for the Model T in order for that car to run.
So can you have multiple lock files, package lock.json files?
No. You should only have one lock file. You should only have one JSON, package.json file. So there should only be one of each.
So if we're going from the motor to like that example and we're trying to upgrade it to the newest stuff,
yep.
How does that compile into both profiles so it integrates well?
Sure. So what happens is if I run, so the question was, let's say that I want to upgrade the aforementioned Model T to have the newest engine. This is some people's entire jobs. So there are companies, so the way to tackle that is that we delete the package lock JSON and we basically reinstall it, and then it'll create a new package lock JSON once it works.
And how do you make sure that every library that you've installed, that you continue to make sure that those are installed and make sure that they're also locked in? So
That's the question of all time. I don't have a good answer.
Yeah,
that is a good question, and I don't have the time to answer it because I don't, mostly because I don't know the answer as well. But the idea is you want to keep your code up to date at all times. Like the most up to date library, you want to make sure it doesn't blow up any tests. That's why we have those tests, those end-to-end tests, and those unit tests as well. But it is a constant battle for every single company because things update on such a quick basis. If you update some stuff, it might break other things. And nobody has the time in the world to tackle all of those problems because you have to make this feature and that feature to make money. We'll talk about technical debt shortly. Let's take a look at yesterday's challenge, if I can ever find it, credit check. All right, I'm not going to fork because I have admin privilege. Actually, I'll just fork, it's fine. All right, so I forked it over. I made a photocopy from India into my own username. I've got the clone link right over here. I'm going to clone this down to my machine. CD into the desktop. I would recommend having like a code platoon exercises folder and just dumping everything inside of there. You might do that already. So I'm going to have this credit check, CD into credit check, and open the whole thing up in the current window using code space dash R space dot. Now I'm going to check out immediately to a new branch so that I'm not altering the original, called John's branch. And you want to do this inside of JavaScript. So I'm going to open this up and then open this up. And it looks like I've got some driver code and I want to change this to unit tests. Knowing what I know, which is not much, I'm going to just run through this installation one more time. So first things first, I'm going to create an npm init. Actually, I'm going to cd into the JavaScript folder. npm init. Press enter a whole bunch of times. And then I'm going to install Jest. This will take a little bit of time because it's installing so much JavaScript underneath the hood. Let's go back and see what else we need to do. Looks like we need to change the file name to something.test.js. Right? So maybe I'll change this to creditcheckspec.test.js. And I want to translate the driver code that I've got to unit tests, which should be pretty simple. All right, I believe I also need to add this to my package.json. So under the scripts, every time that I type in the word test, I actually need Jest. So inside of package.json, get rid of what's there right now and put Jest. I am going to translate this to unit tests and watch it fail. So I'm just going to copy this whole thing. Const cc require credit check. Cut this, get rid of that. And I'm just going to go one by one. So test returns true for valid numbers. And expect cc.credit. Let's just put this in there for now. Expect cc.this to be the number is valid. And I think I can do that multiple times in one test. So I'm just going to copy the line by putting it anywhere on the screen, Command-C, and press Command-V to insert it twice.
I was just noticing, see how the CC dot, or CC, sorry, dot
Yeah.
check.
I
think it's an export on the.
Probably the export. So I'm going to change these numbers and put them in there. I'm going to add another test for returns false for invalid numbers. I'm going to put in all of this. I know that valid is going to show up 3 times, and I can probably update all 3 at once. So type in invalid just like this, and I'm just going to replace these one by one. I think there's a typo in here, isn't there?
Yeah.
The number is valid. These are like identical numbers. Are these identical numbers?
Yeah.
It's not. It's actually not. Interesting. Are they really not the same number?
Oh, they know. The first one is.
Because if it really is this exact same number, I should be able to click on it, and then Command D, and then it'll give me the next one. So I guess they are different numbers. Interesting. All right, so let's exports credit check, which takes in a function. Let's see if this runs. npm run test. Okay, something blew up. Expect cc.creditcheck to be. Maybe it's just credit check, or maybe just that. Let's find out. Well, let's go back to the way that things were before. Module.exports equals sum. So worst case scenario, I can do modules.exports equals check credit. Then I'll create a function called const check credit. It takes in a input number and then a fat arrow. Nothing for right now. Check credit. I'd probably remove check credit. Yep. So let's see if this runs. I'm going to clear the screen. Run the tests.
Please, I'm sure they're not the same.
No, because you exported the function, right?
I did export the function.
So you'd have to use check credit.
Oh, I'm sorry.
No, but I required it differently coming in. I might only be able to do one per test. Let's find out.
Could you scroll up on the error? Ads from
Sure.
Hold on. See, I want to quantity a little up higher.
This thing.
Too strict equal. We had to use on some of the tests because of the data type, so 2B.
Oh, okay. Let's take a look at that. So 2B. Using matchers. To learn about all the other things that Jest can test using matchers. To be, to equal, maybe to equal. Let's try that. Come on.
So what I see is the require saying that you're requiring the credit check
File.
file.
Yep. I expected to see this and got that instead. Deep equality. Let's see. Truthiness, numbers, strings, to match perhaps. Well, I think it's good. What's that? Let's find out. So the question was, does it matter that I'm not returning anything in the function? So I'm just going to return the number as valid and see if this test passes. Clear? Should have one pass, one fail. So everything blows up. One passed, one failed. Did I run the test incorrectly?
I don't think your function is.
Yeah.
Based off the test outline.
We did. Well, I mean, he just ran it and it passed now, so it's being ran.
Let's test this. So this should just run. Yep, so that is true. This one blows up. Let's try a bunch at once. See if this one passes. Oh, whoops, this one, yeah, you're right, you're right. All right.
Did that pass when you had it at the
Yeah, it did. Unless I typed something wrong here. To equal, the number is invalid. Okay, so let's just try to get this first proportion to pass here.
Oh, wait, do you have an else on the credit check? Equal invalid? Because it's comparing the string.
Yep. So this one will fail because I only have valid. Okay. I think the tests are okay for right now. Let's actually write the code, and then we'll get this one to run afterwards. So let's read through this. So credit check. Oh my God. Okay. Oh my gosh. Okay. All right. You gave me the worst one to finish in 10 minutes. All right, hold on. Let me get my other answer up just in case.
I mean, you could also use one. Can you push the right one? Yeah.
That's fun. All right, so let's take a look at this. So we said the way that this one works is you take in a number and you return out some sort of string. So from the rightmost digit, which is the check digit, moving left, double the value of every other digit. If the value is greater than 9, then sum the, okay, I'm just going to grab this whole thing and put it inside of here. So let's see how this one works. So if we have this as our sample input, we are starting from the end, moving left, double the value of every other digit. So this one comes down, this one gets doubled, this one comes down, this one gets doubled, this one comes down, this one gets doubled. If it's over 10, then we sum them, and we sum the whole thing, modulus 0. Okay, that's pretty simple. So let's write out some code. Pseudocode. Create a method called checkCredit. Takes in an input number. Reverse the input number. Pretty much immediately, you got to reverse the input number because you're starting from the other end. Or you could do, or you can start the loop from the end. Reverse the number or start iterating.
Doesn't matter.
From the end. It does. There are even and odd numbered credit card numbers.
Really?
Yeah. So American Express has 15 numbers and Visa has 16. So you must actually follow the rules. It's not as easy as saying, like, if I start from the beginning and I double, then it'll work every single time. So you either have to reverse the number or start iterating from the end and go to the beginning. Okay. If the index of the number is every other one, I believe is odd, then double it. Check if it's over 10. Double it. That's it. If the doubled number is more than 10, add the two digits together and insert that into the array. Else, insert into the array. Speaking of the array, I don't have an array. Let's say create an array called modified numbers into the array. So instead of calling it the array, I'm going to call it modified numbers. See it. Else, have fun on Monday. Into modified. Add all the numbers in modified numbers together and see if the modulus 10 is equal to 0. If so, return the number is valid. Else, return the number is invalid. So I've done this a lot of times. That's why I'm able to pump out the pseudocode. But this is essentially the steps I'm going to take, and I can copy this over from JavaScript to Python fairly simply. So one by one, create a method called checkCredit, takes in an input number. Done. Oh, oops, done. Number 2, create an array called modified numbers. So let modified numbers equal an array. Reverse the number or start iterating from the end and go to the beginning. Which one would you like to do?
I don't like the runtime reverse.
Okay, let's take in, so input number is coming in as a string. So I'm going to set up a for loop. Let I equal, input number dot length minus 1. I is greater than or equal to 0. I minus minus. If the index is odd, then double it. Shoot. How do we keep track of the index? So we're starting from the end.
I like this.
Is it negative?
What's that?
When it's just that.
No, you don't I plus plus though. Like
So you want to go down.
yeah, you go down.
Yeah.
Right.
So let's take a look. This one is really simple because I believe the length of this, if I'm not mistaken, it's 16. it's really easy for this one because it's an even number of digits, but there are odd number of digits as well. So you do need to keep track of, from the very end, if I were to reverse the string and start iterating from the end, it's basically saying this one is supposed to be doubled. This one is supposed to be doubled. So 0, 1, 2, 3, 4, 5. So I know that that index is odd every time. But if I start counting from the end without keeping track of an index, then I'm not sure. What's that?
Well, in your loop, it's going to be the even number of eyes.
Not necessarily.
Negatively.
Not necessarily. That's the thing. We got to create one function that can take care of everything like that.
Oh, yes.
I'm not understanding the problem. We're trying to find the odd ones.
Yeah.
So I modulus 3.
Well, let's see. If we do 16i is equal to 16 numbers or 15 numbers. Yeah, this is where it gets a little bit. Is it? Is it odd?
I think it's so.
Every other
when-
number.
If you are, if you start from the end of the array, right? You can iterate to each one, and whether it's even or odd, you do a mod 2, and all numbers are either even or odd, so it's going to be every other one. If mod 2 is equal to 1, then if it's double and it's blah blah blah, then you run out that. But if it's equal to 0, you just add.
Okay, I'm about to say.
So okay, we are right here. So if
So
where we
Go ahead.
start? Right here.
yeah, we're right here. I'm not sure that this works.
That I like that's how I did that, and I know that kind of works. So let me
Kind of work.
Well, actually, I really don't even need to. Where we started from?
Line 3 inside the parentheses.
All right. So we are.
Is this? Did I set up my loop correctly?
Well, let I equal infinite over minus length. I is greater than 0. Yes.
Okay.
So-
Now I'm on this step right here. If the index is odd, then double, but I'm not sure which index it is.
So I would do if index if input number at I. If input number right at I, or are we going by the index?
We're going by index only.
Yeah, okay,
we don't
good. So,
care
yeah,
at all
if
about
I-
this.
if
If I
I think we need another variable for
do need another variable, or we can reverse the string at a time, which I would
We're doing
recommend.
this loop.
Wait, if I mod 2 is equal to 1.
Go to back to this doesn't do it.
Going backwards doesn't do you any good. Yeah, so if you're going to do it this way, you do need to reverse the string, or like have some sort of fancy math to say, like, if it's an even number, then do the even number of digits do this. If it's an odd number of digits, do that.
Wait, so why does going backwards not help you?
Right now, we only have a string. We haven't made an array of digits. You have to.
Yeah, we can parse it.
Oh yeah,
So
yeah,
we
we
can
can parse it.
This, flip it around the first one. First thing is go easy college. We're not doing any math.
We're not doing any math yet. That works for me.
We can use this loop to make our array.
Sure. Why not? Let's say, what's that called? Reversed numbers equal that. So I'm starting with the last number, and I'm just going to reversed numbers dot append, or is it push? Push parse int at I. Sorry. Input number at I. Let's see if this small bit of code works. Let's just do console.log reversed numbers. So I'm just going to comment this real quick. I'm going to just do check credit of 1, 2, 3, 4, 5. So the response that I get should be 5, 4, 3, 2, 1. I run this using node credit check.js, and I have 5, 4, 3, 2, 1. And they are all numbers, which is great. So now from here, now that I've reversed the numbers, and I've pushed it inside of this, I think I can continue on. It says I'm going to iterate through this one. So I'm going to do another for loop. Let I equal 0. I is less than reverse numbers dot length. I plus plus. And now at this point, I can do the index stuff. So if the index is odd, if I mod 2 is equal to 1, that's how we know that it's an odd number, because anything divided by 2 that gives you a remainder of 1 is odd. Then I'm going to double it. So I'm going to let doubled number equal, oh God, is it reversed numbers at I times 2. Then you set up another if statement. If the doubled number is more than 10, add the 2 digits together and then insert into the modified numbers. If doubled number is greater than 10, greater than or it's equal to 10, I'm going to need to add them together. I don't know how to do that though.
We parse it as a string and then
Yeah,
piece it together to parse that and that'll be your clear. I don't know if we'll do that.
sure. I don't know how to do it. Let's do it. Add 2 digits together. JavaScript.
Oh, yeah. Oh, oh, stop. You can divide it by 10, drop off the decimal, and add that to the remainder of divided by 10.
I could do that. Let's instead not do that though.
Yeah.
Okay, so if it's greater than 10, I'm going to take the doubled number. I'm going to turn it into. I'm going to split it. Turn it into a string. Let's figure this out.
Oh, when you split it, you can
It's
split
not
that number. But it's not a string right now.
So a.split will give me. That's not a thing. Split. Parse string. A. Is that another thing? Parse str.
No, it's just string.
Okay. All right, so I have string at doubled number dot split. All right, and then I'm going to turn those both into integers.
That's why we moved it.
Yeah, split numbers equals that. And then for, again, another for loop. Let I equal 0. I is less than, actually, we don't even need to do that. We can just do modified numbers dot push. Split numbers at 0 plus split numbers at 1, and you have to parse that whole thing. Actually, I think you can do that, which is kind of nice.
What's that repel thing called? It is called repel.
REPL, yeah. Read, evaluate, print loop. It's just, I just typed node.
You don't have to parse in or add.
Yeah.
It still works.
Did you get the right answer?
I did?
Yeah.
Oh, no, you're right. You're right.
Agree. You got
Oh,
to
you-
start. You need to get
You're right.
ready. That's. So I think that's essentially.
Yeah, we actually made a better function to do it.
Yep.
Because it was
That's the direction I'm going towards. So I think this one works. So if it's an odd number, I double it. If it's greater than 10, then I do this gross thing. Otherwise, I do modified numbers dot push doubled number. If it's an even one, I just simply do modified numbers dot push reverse numbers at I. And then I do a quick check down over here. I'm going to iterate through each one, make sure I get that sum. So for modified numbers I'm just going to say let sum equal 0 for modified number in modified numbers. Is that right? Sum plus equals modified number. And I believe at the end it's if sum mod 10 is equal to 0, return one thing, otherwise return something else. I believe that is the number is valid and the number is invalid. I don't know if this is going to work. Let's just run npm run credit check .test.js. That's why we have the tests. Oh no, what happened? Oh, npm run test. Please pass. No. All right, so I expected the number is valid, but instead I got the number is invalid. Maybe I'll just do let I equal 0. Let's see if this gives me the same thing. One passed. Okay, so I think that works for the valid ones. Let's see if it works for the invalid ones as well. I'll be very surprised, but why not? Please, and both of them work. All right, so one thing, 5 more minutes and we'll be done. One thing that you'll realize is when you have one method that does 17 things like what I've got here, you've probably got a little bit too much. So what I would recommend here is splitting it up. This follows what's called the single responsibility principle. It's this idea that your piece of code should do one thing. And if it does more than one thing, pass it off to some other method to do that. Similarly, I've heard the military is very similar to that. You do your one job in your one lane and just do that job really well. Don't try to go into somebody else. Once that job gets too big, we'll split it into 2 jobs. So what I've got here is my old solution. And what basically I've done is I've split out double and add together into its own separate method. You can read this if you'd like to, but it's essentially the same thing. And then a reverse string option as well. Because if you take a look here, I'm reversing the string right away. Then I got this huge bit of code to like double and add them together and then push it in. So I can probably split this into a separate method, split this into a separate method, and then basically maybe make this a separate method as well. It's like see if evenly divisible by 10 is a method, and then you can just run through that. I hope this was helpful. So what did we cover? We covered how to install Jest and how to run it, how to write some tests really quickly from the driver code. We talked about what package.json is. We talked about npm packages, and we also ran through credit check.